Друзі, всіх вітаю! Вітаємо вас на 7-му тренінгу онлайн-курсу «Основи AI», організований компанією Google Україна в партнерстві з Міністерством цифрової трансформації України, Офісом з розвитку підприємництва та експорту, національним проєктом із розвитку підприємництва «Дія Бізнес» та освітнім партнером Projector Institute. Учасники програми можуть отримати нагороди за результатами тестів наприкінці сьогоднішньої зустрічі. Також будемо раді відповісти на всі ваші запитання, а можливо не на всі, якщо не вистачить часу, які ви можете залишати у полі під відео. І пам'ятайте, що автори 5 найцікавіших запитань також отримують призи. Нагадую, що всі вебінари курсу доступні у записі, а наприкінці тижня ви отримаєте слайди з попередніх презентацій на свої електронні скриньки. Сьогоднішній тренінг він присвячений використанню ML у Google таблицях, і він сьогодні буде проведений англійською мовою спікером з офісу Google, який власне і займається розробкою додатків для Google таблиць. А для того, щоб всім було комфортно сьогодні переглядати ефір і, можливо, було більш зрозуміло, ми підготували такі невеличкі інструкції для вас. Для початку, будь ласка, увімкніть автоматичні субтитри у панелі управління в нижній частині під відео. І пам'ятайте, що протягом прямого ефіру будуть доступні субтитри лише англійською мовою, на жаль. Але приблизно через годину після закінчення прямого ефіру будуть також доступні субтитри і українською мовою за рахунок функції автоперекладу субтитрів. Власне, будемо рухатись трохи далі вже. Сьогоднішній спікер це Річард Стоц, розробник програмного забезпечення Google, спікер щорічної конференції Google I.O., і саме він з колегами працює над додатком до Google таблиць, який допомагає проводити машинне навчання без знання коду одразу в Google таблицях. І саме про те, як користуватися цим додатком, він нам сьогодні і розкаже. Hi, Richard. How are you doing? Can you hear me well?
I can hear you doing well. Thank you very much for the opportunity to be here.
Thank you very much for your time and taking an effort to join us today. We are really excited to hear from you all the updates, all the information that you prepared for our participants today. So wish you luck and see you in the end after the Q&A session.
Excellent. Cool. So, hi everyone. I'm Richard. I'm a software engineer working for Google in Switzerland, and I want to talk to you about simple ML for Sheets, practical usage of AI ML in Google Sheets for non-experts. I'm giving this talk in English, but I hope that with the translated slides, it's easy to understand for everyone. So what you see on the first slide is our little owl, which is the mascot of Simple ML for Sheets. It's a friendly and wise owl, and it will pop up from time to time throughout the presentation. So I hope it always gives you a warm feeling when you see it. So let's dive right in. I want to talk to you about machine learning today. And machine learning today mostly has 4 high-level steps that you generally follow when you're faced with a machine learning problem. So the first step you need is you need to have expertise in the domain where you want to apply machine learning. For example, if you're in the banking industry, if you work in finance and you want to, for example, build a machine learning model that predicts how likely a customer is to default on their debt, then you need some knowledge about how debt works, how the finance industry works, in order to even start building a model. Similar with the medical domain, if you want to predict, for example, how likely it is that a certain drug will have an effect on a patient, you need detailed information, detailed domain expertise from the medical field in order to even start building such a model. And the same applies for industrial domains or small businesses. Then the second point is you need generally to use a programming language. For those of you who know programming, you've probably heard of some or all of those that I've listed here. The most popular one for machine learning is certainly Python, but there are others such as R, which is a statistical language, or Java, which is very popular in the business world, JavaScript, which is the language of the internet, and Go, which is another scripting language. So in order to do machine learning, often you have to use such a programming language and know how to use it. It's specified knowledge in itself. Third, if you want to do machine learning, you also need ML expertise. So what do I mean by that? Well, there are tons of different facets of machine learning. There, for example, are different types of models. A model is generally a statistical idea on how we see the world in very high-level terms. And there are different types of models, such as neural networks, decision trees, support vector machines, linear models, etc., etc. And you need some ML expertise in order to decide which of these models to take. And other questions also come to mind, like I need to split between a training and a test set. How do I frame a model? Is this a regression problem or is this a ranking problem? All of that is more specialized knowledge that you need. And finally, and maybe most importantly, you need patience, because first and foremost, machine learning development is an iterative process. I can say from experience that whether you work in a small 1 or 2 person team, or whether you work in a 50-person giant machine learning experts team, machine learning is not a magic bullet that you apply to something. Rather, you iteratively build models that get better and better, and then you try out some things. And this process takes time. So patience and openness to exploring things is really key to being successful in machine learning. So this, I hope, wasn't too scary, but we as a team at Google, we thought, well, how can we make this simpler? How can we help people in this process? And we decided to focus with SimpleML on the second, third, and fourth point of this list. So we want to get rid of the programming language. People should not have to use a programming language. They should use a tool that they already know, such as Google Sheets. We want to drastically reduce the amount of ML expertise that is needed in order to build a model. And we also want to speed up the process. You will still need patience if you build a machine learning model, but at least the steps that we can speed up should be sped up. And yeah, this is what the little owl tells us. This is what SimpleML was set out to do. So without beating around the bush any longer, what is SimpleML for Sheets? SimpleML for Sheets is a Google Sheets add-on that you can use to do machine learning without coding, with minimal machine learning knowledge, and without sharing data with third parties. So let's go over these 4 core values one by one. So a Google Sheets add-on is, well, just that. It's an extension of Google Sheets. Google Sheets is a tool that you probably know for inspecting tabular data, for creating spreadsheets. And an add-on is an extension, a free extension for Google Sheets. Then we want to use machine learning without coding. So as I said, everything is done through a user interface where you can just click on things. You don't have to know programming. Similar, we want to minimize the amount of ML knowledge you need. So we rely on good default values where you don't have to configure, but SimpleML for Sheets itself picks reasonable values for all the thousands of parameters that a machine learning model has. And finally, without sharing data to third parties was really close to our hearts. SimpleML for Sheets was designed to be to not share data with anyone but you and your Google Sheets. So you have your data in a Google spreadsheet, and this data never leaves this narrow line between you and the spreadsheet. It's not uploaded to any third-party servers. It's not uploaded anywhere that you wouldn't want to. It just stays in your sheet, and all the computation is either done directly in Google Sheets or on your own computer. And why did we do that? Well, we wanted to democratize machine learning, and we wanted to facilitate machine learning development. In fact, these are things that our team has been doing inside Google for many years, and we wanted to open that to everyone and build a great platform to learn machine learning too. So everyone should be able to use the power of machine learning for their use cases and improve their decision-making through machine learning. Okay, so this was a lot of high-level talk, a lot of values, etc. But what does that mean in practice? And if you want to see things in practice, well, we need a website. The website is simplemlforsheets.com. And now I will go to that website. You can either follow the presentation directly. This is probably best, but you can write down the website or look at the slides later on to do all the things that I will demo, because then after showing you the website, I will do some nice demos to show you exactly how SimpleML for Sheets works in practice. So let's go to the website. So I hope that you can now see the website. Yes, there we are. Okay, this is simplemlforsheets.com. This is our website. And you can see, well, some of the things that I already talked about. Most importantly, you see our owl. You can see a video with myself and Mathieu, who built this add-on with me. And you can see the install add-on link that I now clicked on. This takes you, if you're logged into your Google account, to the Google Workspace Marketplace, where you can, with a click on the blue button, install the add-on directly into your Google Sheets. So that's it, just one click. You may have a small screen to confirm, and that's all the installation there is. Okay. I will not click it now because I've already installed it. So I would say we go back to the presentation and go to the next slide, which is the agenda. So because now I want to talk to you about how the rest of the talk is going to go. So we've discussed what SimpleML is. Now, the main guiding principle of this talk is that I want to show you how SimpleML works through practical demos, demonstrations that you can repeat yourselves in order to solve the problems that you are having. So the first demo is detecting breast cancer. This will show you how to solve classification problems. Then maybe the second demo will be red wine quality. Very fun. The third one might be very interesting for those of you working in retail, because it's forecasting sales in retail. And finally, the fourth demo is really fun. It's about penguins and taking wrong notes and how to detect when you made mistakes in your data. And we are going to close off the presentation with a look at what SimpleML can and cannot do, how SimpleML works, and some tricks and traps when using machine learning in general and SimpleML for Sheets in particular, and some resources for you for further for further study. Good. So let's look at the first demo. So the first demo is detecting breast cancer. And this is a very classic task in machine learning. So the goal is to assist the medical diagnosis, benign or malignant, of breast cancer using physiological measures. For a bit of context, we'll be looking at the Wisconsin breast cancer dataset that was devised roughly 30 years ago by researchers who had roughly 550 patients with breast cancer, and the goal was to detect whether it was benign or malignant. And the researchers at the time, they collected certain data about their patients, and they also, through very complicated and invasive methods, tried to determined whether their cancer was benign or malignant. And then their question was, well, could we have gotten this diagnosis more easily and without invasive methods by just looking at these physiological data points that we collected? Okay. So let's go to the first demo to see how that looks like in practice. Yes, there we are. Excellent. So this is the data that I have. These are the features in green. So clump thickness, uniformity of cell size, uniformity of cell shape, etc. Mitosis. I have to say, a software engineer and not a doctor. So I somewhat lack the domain knowledge that would be needed to really explain each of the features here. But I can look at the data, and it's really useful for us to understand how to make a classification. Because what we want, we can see down here in the last class. The class is not filled out for these first 29 examples or 29 examples. And for everyone else, it's filled out. So benign, these are benign. Down here, these are malignant, benign, malignant, etc. And in total, if we scroll down, we can see that we have 700 or 699 examples. Okay. So what we want is we want to make predictions for these first patients where we don't have a prediction, we don't have a diagnosis yet. And we want to use simple ML flow sheets to do it. So how do we get there? I'm going to scroll a little bit to the right and then click on extensions. I have installed simple ML flow sheets. So here I click on simple ML flow sheets and then on start. Before I click brief note, you can see below that I have simple ML flow sheets Google internal. This is because I am one of the developers of simple ML flow sheets. And we have an internal version where we experiment with new features. And this is why I have this Google internal. You probably do not have it. Okay, let me click on start. I'm waiting for a little bit. And working, there it is. So I get this sidebar on the right. And it says, what do you want to do? Predict missing values, spot abnormal values, or forecast future values. So the correct task here is predict missing values, because I have missing values in this class tab, in this class column, that I want to predict based on the information down here, on the existing information. So let's just click on it. The column with empty cells is in fact class. I click the blue. I don't really care about the other options right now. I just click on the big blue predict button. And now I have to wait. Hopefully, I mean, this is a live demo, so I hope everything goes well, but I shouldn't wait for a long time. And there it is. So here are the predictions that my machine learning model made. Malignant for this first patient, benign for the next one, malignant, benign, etc. And I have these confidence bounds. So for the first patient, the model is 99.45% confident that the tumor is malignant. For the fifth patients, I have only a 75% confidence in the model. Okay. Okay, let's go back to the presentation and talk a little bit more about what just happened and what we can do with that. So back to the presentation. Yep, and what just happened? So we did generate a diagnosis prediction for all the patients where we didn't initially have one. We got a measure of confidence in the predictions, and we actually, in the background, got a lot more. We got evaluations, we got model understanding, and we will talk about all of that later. But for now, the important thing to remember is we essentially had 3 clicks, opening the add-on, clicking on predict missing values, and clicking on predict. And we got we built a machine learning model. We made predictions with the model. And we did not write a single line of code. We did not pre-process or normalize the data set. Those of you who know ML will probably have heard of these terms. Pre-processing is really important for some ML technologies. We didn't do any of that, and we didn't have to configure any learning algorithm or model. We just clicked predict. So looking at the standard applied machine learning steps, we can reframe that as, well, we have defined an ML problem, and we propose a solution. So the ML problem here is, how do we detect breast cancer using physiological methods? And the solution is, well, some combination of the physiological methods. We construct a data set. Well, here this was easy. We got the data set from this 30-year-old paper. And we got our data set into Google Sheets. And then everything else on the standard ML pipeline, transforming the data, training a model, and using the model to make predictions, all of that was done by our little owl with simple ML. What's really, really nice from my point of view is that you can actually construct your data set in Google Sheets. So if you know how to use Google Sheets, you actually also almost know how to use machine learning. And this is kind of the high-level message that we want to bring to you. If you know how to use Google Sheets, that's already enough. Okay, this was the short, flashy version. Let's go into more detail, more demos, and let's discuss a little bit more what we can do with simple ML for Sheets. I'm gonna take a quick sip, rest for just 1 second, and then we'll go to the demos. Okay, I think I'm ready. Demos, and back to my screen. Good. Okay, so we're back. This is back in Google Sheets. This is back to the breast cancer model. I wanted to touch one more point, which is, what does classification even mean? So classification is, there are 2 classes, benign and malignant. These are separate. Benign is strictly separate from malignant, and there's a clear division between the 2. This is different from what we'll see next, regression, where you can predict numbers, for example. But now that we have our model, how good is our model? Well, how good are these predictions actually? Simple ML for Sheets can actually tell you that. So let's look at the actual values. So this is what simple ML for Sheets predicted. I know actually the right answers for all of these rows. And now I could just copy them side by side in Google Sheets and compare them. I can also do an advanced task here and click on evaluate a model. The model is just the last one I trained, so it's the top one in my list. I click on evaluate. And then, again, I wait a couple of seconds. And I get this model evaluation screen. I know this is a little bit hard to read. This is an advanced thing that you don't have to do, but it's instructive for this class. So in this evaluation report, you might see a lot of things that seem complicated, but we can work through them. So we had 29 predictions. We had a task that was classification. Whoops. Oh no, what did I do? Well, oh well. Can I get rid of this? Oh, okay. I hope you can still read it. I clicked something wrong in my web browser. Now the color is off. Anyway, so the label was the class, benign or malignant. Here we have some standard measures from machine learning. If you're an expert, you might know them. Otherwise, just ignore it. The accuracy is essentially tells me how good my model is. The closer to 1 it is, the better. So we've got 0.96, which is really high. And the most interesting thing is below here, the confusion table. The confusion table, again, is a standard tool of machine learning, which tells you exactly for each of the predictions where it falls. So out of our 29 examples, we had 16 that truly were benign, and all of them were actually benign. And then out of those that were malignant, 1 was recognized as benign, and 12 were recognized as malignant. So what does that show you? Overall, the model did a great job. All but 1 example were classified correctly. Still, it also shows you that machine learning can support your decision-making process, but you should always double check, or you should always ask questions. So here, in this case, telling someone with a malignant tumor that his tumor is actually benign might be problematic. So additional measures might be necessary, and you have to carefully evaluate whether the model actually is enough for your needs. Okay, and below that we have some graphs that I'm not going to go into detail now. The experts among you in machine learning though might recognize some of these curves, and it's really nice that SimpleML just auto-generates them for you. Okay, so this was the classification problem. I want to go to something really fun, which is a regression problem on red wine quality. This is a data set of red wine, not Ukrainian red wine, though it's Portuguese red wine, but still maybe a fun topic. So they measured for certain bottles of red wine some of the features of these bottles. So we have acidity, we have citric acid, residual sugar, the amount of alcohol. And then the quality of the wine was measured. You can see it down here on a scale from, I think, 1 to 7. So most of the wines in the data set scored pretty well. So 5, 6, 7. Yeah, I don't think we even have a 1 anywhere. It's pretty good. Pretty good setup. Oh, no, we do have, well, yeah, they're overall pretty good. And now we have some wines, again, where we don't have the data. So we want to predict the quality of these first 21 wines, okay? And we can do it, again, just exactly the same way we did it for the breast cancer data set. We click on predict missing values. Our target is quality. And since this is a second example I'm showing, I'm going to go in a little more detail and click on source columns. Here you see, well, all of the columns are relevant for us. We have advanced options. You can choose the learning algorithm if you want to. And here you can choose some more details in the results. Not super relevant for us. We click predict. And once again, we have to wait a little bit. While we wait, I can explain and maybe can explain what's happening now. What is happening is actually the data from your Google Sheet is transferred to my computer, to my local machine. Then the entire machine learning work, the entire model training and prediction making is run on my own machine. And this is great for privacy. The data really stays between me and Google Sheets. And this is also why it takes a couple of seconds. All of the data has to be actually transferred between the Google server and my own computer. And then as soon as the data is processed, it's transferred back to Google Sheets and put into the spreadsheet. And if you want to know more, you can also click on Show Extended Logs here. There's nothing in there for the moment, but now it generated something, and you can see the predictions. So let's increase this column a little bit. So, and here you can see predictions. So this wine gets a 5.2, this wine only gets a 4.8, this wine gets a 5.1, this one is great, it gets a 5.4, etc. And the difference to our previous example really is that we predicted a number. We didn't predict good or bad wine, we predicted a number on a scale from 1 to 7. And SimpleML for Sheets automatically deduce that since the target column here, quality is a number, we might also want to predict a number. Okay? And it's not a classification problem, it is what we call a regression problem. Great. People often ask us, well, where is the confidence interval here? And as of now, we don't show confidence intervals for these numbers. It's also mathematically a little bit different to show confidence intervals for numbers, but it's something we're interested in. Okay, so again, we could check. So I have put the original values here. You could check the differences if that matches, but I think I'm not going to do that. And go to the third task, which is extremely relevant for anyone here who works in retail. So this is again a very, very classic task that almost every retailer, every business struggles with. It's predicting future sales. So in our example, we consider a store that has shops in London and New York. And it sells two things. It sells toys and books. And we have past sales data from that store. So here in the week, this is weekly data. So in the week of February 5th, 2010, we sold 2,592.45. Well, these are clearly divided numbers of toys, and 3,500 books. And in New York, we sold 5,600 toys and 7,400 books. Okay, and we have this data for roughly 2 years. 2 years. Okay, and we want to predict the future. So based on past sales, what will our future sales will be? Why is that useful? Well, if I know what my future sales will be, I can answer questions such as how much should I order? How many people should I hire? How much space do I need? How much storage space do I need? All of these questions I need to answer, and I can support this decision-making process by making a machine learning model of my past sales and use it to predict my future sales. With SimpleML for Sheets, this is super easy. I'm going to show you how to do it now. So again, we are in SimpleML for Sheets in our main window, and we click on the third task, Forecast Future Values. Clicking on it. Forecasting always needs a time. Like you forecast forward in time. So you need a column that is the time. Generally, we use the first column as the time column. So this is already correct here. And we see that it correctly recognize the date column as such. And then we have these 4 stores. The 2 lines in yellow, location and departments, are also relevant for the model. Why is that? Well, you could see that the sales in different locations are correlated. So, for example, if there is a big holiday in the UK that the US does not observe, that New York does not observe, then the sales in London might be larger during that time, but the sales in New York will be unaffected. So the location of the store is clearly important. Similarly, there might be some effects where toys sell better, both in New York and London at the same time, but books are unaffected. So this is why it's important, and if you have this information, it's useful to provide it to the model the way we do here. Okay, you can see those as so-called column categories here in the first option. Both location and department are chosen. We have a lot of advanced options here that we expose, but the first one is magic. You can look at all of them by just hovering over the eye. Like the trend is a long-term component of forecasting, the growth, seasonality mode, holidays that you want to observe. But it's generally not necessary to change any of these options. You can just, again, click on forecast, wait not too long. Forecasting is generally very fast with our model. And there, down here, we see the sales numbers, but numbers are numbers. You can also see here a chart of your past sales and future sales. So here on the left are the past sales of each column. So the top one, C4, is books in New York. And there starts the predictions. So here starts the predictions of the future sales. Okay? And you can see, for example, here, that the model is able to pick up these seasonal effects, because forecasting often relies on seasonalities. If you think of book sales or toy sales, those, especially in London and New York, will be much, much higher during December, where people buy toys and books to gift for Christmas. And the model is able to pick up on these trends and incorporate these effects into the forecast. And I really encourage you to play around with this if you work in retail or if you have a small business. It's really useful to have an idea on what future sales might be and how to use them. Finally, I want to go to the last step, which is detecting abnormal values. So what do I mean by that? So again, let me go into a little bit of detail on what the data set is that we're seeing here. Here we have the so-called penguin data set. Penguins are almost as nice as owls. And the penguin data set is a data set where some researchers looked at penguins in Antarctica, recorded their bill length, their bill depth, their flipper length, their sex, the year they were found, and the island on which they were found, and also determined the species of each of the penguins. Okay? Suppose you are that researcher, and you have in Antarctica made all these observations. You've written everything down, but for some columns, someone, maybe you or a colleague, have unfortunately changed the species. So some of these rows are wrong, have the wrong species in them. Can we use machine learning to automatically detect which rows are most likely to be wrong? So for that, we click on Spot Abnormal Values. We say, well, which is the column with abnormal values? It's the species. We click on Spot Abnormal Values. We wait a little bit. And then let me scroll down. Yeah. And then we see, oh, okay. What does the model think? the SimpleML for Sheets thinks that this row is actually faulty because the species in the row is Gentoo, but the model would have predicted, based on the characteristic of the penguin, that the right species is Adelie. The third row is also wrong. Adelie is the species that's in the sheet. The model would have predicted Gentoo, and so it gets a high abnormality score. Here's another one. Here the abnormality score is not that high, so it's 68. Here we have another one where the abnormality score is high, but actually we don't have a lot of data for this one, so maybe that row is not useful at all. And again, I have the correct data, so we can see that actually for the second and third row, the model was right. So these were actually incorrect. Adelie and Gentoo are correct, and not Gentoo and Adelie, so they were flipped out. The model is able to pick up on these things. So what can you use this for? Well, whenever you have data that you got from somewhere, and you think that data has been tampered with or has been damaged or something's wrong, or you just want to see if there's something wrong with the data, you can use the task spot abnormal values to get an idea on where issues with the data might lie. Still, I want to caution you a little bit on that. Just mathematically, if you have a large enough data set, some outliers will be there, and this is normal. Like, it's, in other words, it's normal to have some abnormal values. This is just how the mathematical equations work. But it's useful to still look at everything that was predicted as abnormal by SimpleML for Sheets and, well, double check. Okay, this was it for the demos. I hope that I didn't overload you too much with too many spreadsheets. I encourage you to try SimpleML for Sheets at home and try to do all the things and play around with the demo. Do the things that I showed here. And let's go back to the presentation now for some summary of what happened. Okay, so let's be a little more formal. People tell me to be more formal. I'm just wearing a t-shirt. What does SimpleML for Sheet do? What can it do? What can it not do? So it supports three things: supervised learning, predicting a class or a number. This is a classification task or a regression task. So typical questions are: is this person sick? Will this car fail? How many hours of work are needed? These are classic supervised learning tasks that you can solve with SimpleML for Sheets. SimpleML for Sheets can also do forecasting, so predicting a sequence of future values. Typical questions will be: what will the weekly sales be for the next 6 months? And then it can do abnormality detections, so it can detect abnormal measures in a data set of measures. And the question that you answer here is fairly simple: are there incorrect values in my data? These are the things that it can do. It supports tabular data, so the data that can be written in a table or a spreadsheet. It has some limited support for text data. So short text snippets are fine. If you have like 10 or 15 word text snippets and those are in your table, those are fine. But large text, like multi-paragraph text, even if you somehow put it in your spreadsheet, large texts are not really supported by SimpleML for Sheets. It will A, be fairly slow, and B, it will also not give very good results. So for large text, you have to use other methods. SimpleML for Sheets is for short texts or numbers. SimpleML for Sheets does not support images, audio, other data. So graphs, for example, videos, all of that is not supported by SimpleML. And it also does not support huge data sets. This is just a limitation of Google Sheets. So Google Sheets kind of becomes slow and ineffective if you have more than 10,000 rows. How does it work? I don't want to go into too much detail here on how it works. But since the technology is also developed by the team I work in, and this is close to my heart, so the technique we use for making predictions, so for predicting missing values, is called decision forests. And it's a machine learning technique that mimics human experts. You can see such a what we call tree on the right of my slide. So if we want to predict the species of an animal, we can say, oh, how many legs does it have? If it has less than 4 legs, well, I predict a penguin. If it has more than 4 legs, I ask another question, which is how many eyes does it have? If it has less than 3 eyes, it's probably a dog. If it's more than 3 eyes, then it's probably a spider. This, of course, is a very simplified version of a decision tree. But what the software actually does is, out of all the possible trees, it generates the one that are most fitting to the training data and combines many of them into a decision forest. Okay, and for forecasting, it uses the ARIMA and ETS models. Again, I'm not going to go into detail here. These are very classic models. You can read up on them on the internet, that are really good at predicting these seasonal effects that are often present in real data. The important thing is this doesn't matter. It doesn't matter how simple ML works. What you've learned so far apply to all ML technologies, and ML practitioners generally apply multiple techniques and use the one that works best for them and their problem. Classic ML technologies such as decision forests are really well suited for tabular data, and this is why we chose them for simple ML for sheets. If you want to learn more, I encourage you to research that. Deep learning, I think, will be talked about more in this series of talks. It's great when your data has a complex structure, such as images and text, or when you have a lot of data. Decision forests that are used by simple ML for sheets give great out-of-the-box results where there's not a lot of data and when inference time is critical. And ARIMA ETS are classical solutions for what is called time series forecasting. Now to the last big topic of my talk, tricks and traps. So there are essentially 3 traps or 3 questions that I want to highlight here. If you say, well, I used simple ML for sheets, but my results look weird, most likely there is some problem with the data. You have to make sure that your data is correctly structured. It's really useful to go to simplemlforsheets.com, the website that I showed in the beginning, and read up on the documentation whether there is anything that simple ML for sheets expects that your data is not doing. And it's also really useful to plot your data, to see with a plot, which you can easily do with Google Sheets, if simple ML, if the data in your sheet is actually correct. If your model isn't perfect, don't stress. Models are rarely perfect, almost never. You have to make sure whether there is a relation between the target column and the other columns. And you should consider if you have enough data. If you have less than 200 training examples, training is hard. You can use the random forest in the advanced menu, which is particularly, so it's an option in the advanced menu, which is particularly well suited for small data sets. And if your model is perfect, maybe you're lucky, but you should be extra careful. As I said, models are rarely perfect, so possibly you somehow misconfigured simple ML for sheets, or your data actually contains something like data leakage. Data leakage means that you the value of your target was actually present in your data. So for example, if you actually have a column, if you go back to the breast cancer example, that says malign or malignant or benign, and then you will also want to predict malignant or benign, the task for the model is really easy. It just copies from one column to the other. So make sure that your data is not fishy. Okay, what's next? If you want to learn more, there's options for that. Simple ML for Sheets is really enough for a lot of people. You can create ML models and support your decision-making with it, but if you want to dig deeper, either out of necessity or curiosity, some pointers on the slides are TensorFlow Decision Forest. This is a technology developed by the team I work in, so the team that also builds simple ML for Sheets. This is a classic ML tool, so using a programming language, using the TensorFlow ecosystem. It's really powerful. You can create, build machine learning models on billions of examples. But it has a learning curve. You actually have to learn how to use it. Feel free to check it out. Feel free to send messages to us on GitHub if you have questions. And you can also export the simple ML models to TensorFlow or run them in C++, in JavaScript, or in Go, and check out the documentation for that on our website. Some more resources. There is the Simple ML for Sheet website, the demos, and the different machine learning classes that we have for here at Google. The classic machine learning class, the Decision Forest class that was written by our team, and just different tutorials on TensorFlow Decision Forests. And that's all I have. You are now an ML wizard, just like our little owl. There it is, finally. Thank you very much for listening. I know this was a long talk, and I'll be happy to answer your questions. Oh, wow. Okay, so let me. I have a long list of questions here that I will go to. Let me go through them one by one. So okay, I'll start with this one. How does the Simple ML program in Google Spreadsheets handle outliers and anomalies in data when building a machine learning model? Does it have automatic mechanisms to detect and fix these anomalies, or does it require manual intervention by the user? So let me put a note here. Okay, the answer is it does handle outliers and anomalies automatically. So let's talk about forecasting more specifically. Sorry, not forecasting. Let's talk about predicting missing values more specifically, because it's easier to explain there. The machine learning technique that's used there, as I said, is decision forests. And decision forests builds these trees. These trees are could be configured to be very sensitive to outliers. But the way we configured them is actually to use hundreds, I think 300 trees. And together, they are designed specifically through randomization to be very resistant to anomalies, especially if you pick the random forest setting. The random forests are surprisingly resistant to outliers, and it's really part of our philosophy to automatically detect these things. Okay, next question. Can we use APIs like those of OpenAI or TensorFlow with Google Sheets to implement machine learning models? This is kind of outside of what I'm really familiar with. It. You can do so, but it's going to be more work, and it's outside of what I'm really familiar with. If you want to look in that direction, you can look at Apps Script, which is the technology to build extensions for Google Sheets. And you can also, in Google Sheets, look at the app sheet. So in the extensions menu, you probably have the app sheet menu. There you can more easily create apps, very complex machine learning apps yourself using a lot of Google Cloud technologies. So the next question, can Google Sheets handle large data sets for machine learning? What are its limitations and how can they be overcome? So as I said in the talk, the soft limit is 10,000 rows. After 10,000 rows, Google Sheet itself becomes slower. And yeah, the machine learning model is happy with more data, but Google Sheets specifically is not built for this large of data set. If you have larger data set, you will probably want to use more advanced, more manual methods, such as learning a bit of Python and installing something like TensorFlow decision forests, like the Python library or any other ML library. And with TensorFlow decision forests, I have seen people train on billions of examples. So there are limits, but there are more the physical limits of the computer that you have, not really in the software. Okay. Next question. Can I integrate machine learning models created in Google Sheets with other tools or platforms such as websites or applications? Yes, you can. Maybe I can show that very briefly. So if you can, I don't know, if you can share my screen. If I can share my screen again, then I can show you very quickly how to do that. So if you're in SimpleML for Sheets, in the advanced tasks section, you have export a model. There you pick the model. Here I have a lot of models that I created. If you predict missing values, those models are automatically saved. You can also train models by hand. Then we click on export. Whoops. We wait a couple of seconds. Wrong setting. So I click on export, building code like the example. Okay. And this is your model. So your model is actually saved in Google Drive automatically. And you can immediately just take this code that you have here. This is classic standard Python code, and use this code in Google Colab, which is an IPython instance. And yeah, then use this model in all the ways that TensorFlow Decision Forest supports. So you can use the model on their website. You can export it. We have a tutorial on simplemlforsheets.com how to export it to TensorFlow.js, so you can use it on a website. You can use it in Python, in Go, in all kinds of environments. So this is very, very flexible. Just click on export model, and then you get the Python code you need. And the models are also saved in the SimpleML for Sheets directory of your Google Drive. And these are just standard TensorFlow models. If you know TensorFlow, if you have worked with TensorFlow, you can import those with TensorFlow Decision Forest and use them in TF Serving or other tools. And if any of what I just said sounded like gibberish to you, that's fine. You don't have to do that. This is something really advanced. Okay, I think we can stop sharing my screen now. Yeah. Okay, next question. Are there any specific data visualization techniques or tools within Google Sheets that can help in analyzing and interpreting the results of machine learning models? Yes. Okay. So there are tools. I'm not the most familiar person with Google Sheets. I'm very familiar with SimpleML for Sheets. For me, the most important thing you can do is plotting. Just simple plotting is 95% of what even professional ML engineers at Google do to analyze their data. This is like the most important tool. Just looking at your data, looking at all the plots is really, really useful. Within SimpleML for Sheets, if you remember, I showed the evaluation part of the model, so evaluate model. This also creates you all kinds of metrics and plots of your data and of your machine learning models that are really useful to analyze what your machine learning model is doing. And then I just encourage you to look at the Google Sheets documentation for all the other data validation, column statistic, it's data cleanup tools that it provides. That's a bit too much to go into right now, but there are a lot of tools available. Is there a performance difference between SimpleML for Sheets and building your own machine learning? Because the spreadsheet is much simpler. Well, it's nice that the spreadsheet is simpler. So will there be a performance difference? I'm assuming that you're talking about performance, like model performance, model quality. SimpleML for Sheets produces high quality models that are absolutely on par with what you can do with your own ML. The technology is really built. If you're using SimpleML for Sheets for data that it was built for, so tabular data, no video, no images, no long text, then you will get high quality models. Of course, an experienced ML engineer with a lot of time can always tweak out more from a model. Our team has been very happy, and we've had good successes with customers working with SimpleML for Sheets. If, of course, one limitation is the data set size. So for some tasks, if the relationship that you want to predict is extremely complex, you might need a lot of data, and this is not doable in SimpleML for Sheets, as I said earlier. How to determine the list of necessary parameters needed to build each model? What are the main ML parameters on which Google Sheet works? I'm not 100% sure if I understand the question correctly, and unfortunately, I don't have a way here to see the question, so to interact directly with whoever asked that question. So let me interpret that question. Parameters of the model itself. So how, possible parameters is how many, what techniques do we use? Decision forest, neural networks, support vector machines. How do we, for a specific model, configure that model? So for decision forest, that would be a question of how many trees. How do we split between trees? These parameters are chosen automatically by Google Sheets. Two values that we have had good success with, or that we know are generally good. SimpleML for Sheets uses machine learning techniques that are fairly robust. So you don't have to tweak the parameters, really. They're built to work with the default parameters and work well with the default parameters. And we've spent a considerable amount of time finding out what good default values are. If you're an expert on decision forests, I can tell you that SimpleML for Sheets uses decision forests with 300 trees, which is not on the high side, but on the medium side. Other than that, generally uses those parameters that were suggested by the original authors of this machine learning techniques when they invented it. And we've had very good success. For forecasting, we actually took a lot of time to try a lot of data sets to get really optimized parameters for the algorithms. I hope this has answered the question. Okay. When processing, one second, I cannot properly read this. When processing simple ML in Google Sheets, is there a direct relationship between sample size and prediction accuracy? Does it mean that when the table is constantly replenished with new data, will the accuracy and adaptation of work algorithms to the new volume of data increase? So, generally, more data means higher accuracy. This mostly is true as long as, and this is extremely important, as long as the relationship between the features of your data and the label stays the same. Like mathematically, we say whether all the distribution does not change, the probability distribution between your features and the label should stay the same. If you add new data and the new data describes a different process than the original data, then you will actually hurt the model. So what do I mean by that? Let's say let me make up something. Let's say you have students and you have data for your students in let's say a high school, and you want to predict whether or not you need extra support for them. And you have some information about the students. You have to be very careful with privacy. But you may have some information about the students, and you're allowed to actually use that information in Google Sheets. And then you build a machine learning model. Classification model needs extra help, does not need extra help. Okay, then this model might perform well, but if you now say, oh, I want to add more data, and now I will add data from, let's say, a different high school, or from students that are much, much older or much, much younger, then this extra data is just so different from the original one that this will hurt your model. Your model will get confused. Why is now the new data different? So you always have to make sure that if you add new data, it comes from the same distribution. It describes the same process. And then, of course, there often is diminishing value in adding new data. So there is this, but this is highly dependent on the problem you're trying to solve. So at some point, generally think of this as a logarithmic process, although it doesn't have to be. The extra learning that the model can get from new data roughly halves every time you double the amount of data. So initially, extra data is great. At some point, extra data doesn't really help, because the model has already learned everything there is to learn about the process. Okay, final question I have here. Yes, final question. Can I be sure the forecast was built according to the model I am interested in? Maybe I want to calculate other indicators, and the obtained indicators can distort my initial data. I'm not really sure how to answer that. So yeah, I think I'm gonna need some clarification on what this question is about. In general, the forecasting models work well if you have data that is somewhat seasonal, that has some trend. So it works great on a lot of data. But if you want to, for example, predict stock prices, this is going to be very hard, because stock prices are generally considered to be mostly random. Or if you want to predict the weather, this is also going to be hard, because the weather at a certain point is very, very hard to predict. There are just a lot of factors, a lot of geographical factors that come in, and a tool like Google Sheets cannot even hold all the parameters that influence the weather. Okay, these are all the questions I have. I hope that I answered them correctly, and thank you very much for your attention.
Richard, thank you very much for your wonderful presentation and for the demos that you showed to our participants. We've got really a lot of questions, but unfortunately we are unable to ask all of them due to the timing. So now I will switch to Ukrainian and we will start our Kahoot. Тож, дорогі учасники, дякую, що дослухали до цієї частини. Сподіваємося, що презентація Річарда і демонстрація прикладів практичних вам дуже сподобалась, і ви зможете вже незабаром скористатися цими ідеями та порадами у власному житті, у власних бізнесах, у власній справі. Ну а зараз ми переходимо до найприємнішого. Це Kahoot, розіграш нагород, і ті, хто з вас не на першому тренінгу цього курсу, вже знають всі наші інструкції, але ми маємо пройтися по ним ще один раз. Сьогодні, на відміну від інших тренінгів, буде один тест, але на вас сьогодні буде 10 переможців. Не 5, як раніше, 10 переможців за тест і 5 переможців за найкраще запитання. Щоб приєднатися до одного тесту першого, ви маєте перейти за посиланням kahoot.it, після цього ввести спеціальний пін-код, який ви побачите на екрані, або скористатися QR-кодом, і потім потрібно буде ввести нікнейм довжиною до 15 знаків. Це має бути електронна адреса до позначки равлик, яку ви використовували під час реєстрації. Так, організатори зможуть вас ідентифікувати та надіслати подарунок, якщо ви виграєте у цьому підсумковому тесті. Правило щодо гри лише в одному тесті сьогодні не дійсне, тому що у нас всього один тест. Тож, дайте мені декілька секунд, і я виведу на екран наш сьогоднішній тест, щоб ви могли вже почати приєднуватись до нього. Буквально декілька секунд. Richard, unfortunately, you won't be able to understand our test, but it is based on your presentation. So just stay with us for a couple of minutes, please.
I wish everyone good luck.
Тож, зараз на екрані ви можете бачити код, за яким потрібно під'єднатися. Також ви можете скористатися QR-кодом на екрані. Чекаємо трошки, розуміємо, що є невеличка затримка у лайвстрімі. Так, зазвичай і відбувається. Саме тому ми чекаємо на всіх учасників. Будь ласка, під'єднуйтесь. За приблизно хвилинку ми почнемо тест. А з прикладами нагород, які ви можете отримати за підсумкові тести та за найкраще запитання, ви можете ознайомитися на нашому веб-сайті на другій сторінці програми. Також на супорт програми ми отримуємо час від часу запити. Ну що ж, коли ж подаруночки будуть розіслані, не переживайте. Після останнього тренінгу в четвер всі переможці всіх тренінгів отримують спеціальну форму, яку буде потрібно заповнити, вказати дані для доставки, а також вказати власні побажання щодо нагород і деякі інші дані, необхідні для відправки. Ось, наразі бачимо, що майже 500 учасників вже долучилися до тесту. Непогано, але чекаємо ще трошки на всіх. Буквально ще декілька секунд чекаємо та починаємо тест. Нагадую, що сьогодні буде 5 запитань в тесті. На кожне запитання ви матимете 30 секунд, аби відповісти. Правильна відповідь лише одна. І також дуже важливо не забувати звичайно, відповідати правильно, але й швидко, тому що найкмітливіші учасники опиняються на перших сходинках, адже Kahoot визначає переможців за правильністю відповідей та за швидкістю відповіді. Тож, я думаю, ми можемо починати наш тест. Ви можете продовжувати приєднуватися до тесту і після того, як ми продовжимо, як ми почнемо тест, але наразі ми вже не можемо далі чекати. Всім бажаю успіху. Тож, починаємо Kahoot. По матеріалам тренінгу, як використовувати ML, якщо вмію користуватися лише Google Sheets. 3, 2, 1. І перше запитання з нашого квізу. Доповнення Google таблиць для виконання машинного навчання без кодування з мінімальними ML-знаннями – це ChatGPT, це Art, це SimpleML для таблиць, або правильна відповідь відсутня. Нагадую, що є 30 секунд, і лише одна відповідь є правильною. 10 секунд залишилося. Останній учасник відповідь. 3, 2, 1. Звісно, тема сьогоднішньої лекції – це була SimpleML для таблиць. Думаю, спікер наш дуже радіє, що ви відповіли майже всі правильно. Рухаємося далі. Наразі це були б наші переможці, якби тест закінчився вже після першого запитання, але ще 4 запитання на вас чекає. Для чого створений SimpleML для таблиць? Демократизація ML, сприяння розвитку ML, чудова платформа для навчання машинному навчанню, або всі відповіді вірні. У вас залишилося 15 секунд. Для чого взагалі Річард з командою створювали такий прекрасний застосунок для Google таблиць? Правильно, всі відповіді вірні. 396 учасників дали правильну відповідь. Рухаємося далі. Що не підтримує SimpleML для таблиць? Зображення, аудіо, графіку. Другий варіант – табличні дані. Третій варіант – короткі фрагменти тексту. І четвертий варіант – немає вірної відповіді. Ще одна відповідь тут буде правильна. Зовсім трошки залишилося секунд. Майже всі відповіли. А як відповіли, дізнаємося прямо зараз. І майже всі відповіли також вірно. Вітаю вас з цим. Рухаємося далі. Класичні технології машинного навчання найкраще підходять для текстових даних, табличних даних, великих наборів даних, або всі відповіді вірні. Добре, подумайте перед тим, як відповідати, але пам'ятайте, що у вас є всього декілька секунд, і переможці визначаються також за Тож, правильна відповідь – це для табличних даних. Так. Тут розділилися думки, але найкраще все-таки ключове слово – вони підходять для табличних даних. І що ж, така у нас таблиця лідерів перед останнім запитанням тесту. Тож, рухаємось далі. Удачі. Останнє запитання. Який зі стандартних кроків по роботі з ML не можна виконати за допомогою SimpleML для таблиць? Трансформувати дані, визначити ML-проблему та запропонувати рішення, навчити модель або використовувати модель для прогнозування. Який зі стандартних кроків по роботі з ML не можна виконати за допомогою SimpleML для таблиць? Того, що показував сьогодні Річард на своїй презентації. І правильна відповідь – це визначити ML-проблему та запропонувати рішення. Тож, дуже цікаво дізнатися, хто наші переможці. І п'єдестал сьогодні виглядає наступним чином. На третьому місці учасник з таким нікнеймом, на другому – таким нікнеймом, і на першому місці ось цей учасник або учасниця. Також на екрані ви можете бачити 4 і 5 місце зараз. Натомість в сьогоднішньому тесті 10 переможців, і не переживайте, ми точно напишемо кожному, хто сьогодні переміг, тому що організатори бачать статистику переможців повну. Тож, на цьому ми можемо, думаю, завершувати наш тренінг. Richard, thank you very much for joining us today. It was a big pleasure to listen to you, to learn new things, new skills. Hopefully Ukrainians, all of them who watched us today, will use it in the future, in their work, in their some life routine, maybe even. So thank you very much for taking your time and joining us today. А до всіх учасників також нагадую, що останній заключний тренінг програми відбудеться вже в четвер. Він буде присвячений побудуванню ML-команд з нуля. Доєднуйтесь до нас і слідкуйте за апдейтами в своїх електронних скриньках. Всім дякуємо, до побачення. Goodbye.
Bye.